In this video, we're going to discuss the TANGO Self Adaptation Manager, the benefits it provides and how to use it. What is it? The Self Adaptation Manager is an event-driven, runtime adaptation manager. So it responds to events within the system that it's monitoring and performs adaptation as required. It monitors values from collectD, which is the TANGO framework's chosen monitoring infrastructure, and it also monitors information from Slurm, which is the device supervisor. It has a set of rules that allows it to decide when to adapt. It can detect events such as boundary conditions on measurements, so when measurements come in from collectD or from Slurm, it can actually set particular conditions and thresholds upon those values. It can also detect idle hosts within the environment, and it can detect idle hosts with accelerators. So this therefore allows adaptation to occur to take advantage of accelerators within the system which are not being utilised. It can also detect the applications which are starting and completing. It can also detect the applications approaching their deadline. So this allows the system to adapt and make sure that changes can occur to make sure the program doesn't terminate prematurely. It can also detect events such as chronic, which are described by chronic expressions. This allows the system to know what time of day it is and therefore adapt accordingly. This may be used for setting certain things such as power caps during certain periods of the day. Of the events and the monitoring that actually occurs, we can start asking ourselves the classic 5 questions of self-adaptation: when, why, where, what and how. So in regards of when to adapt, we can do it reactively, such as monitoring information coming in and setting a particular threshold, or we can be more proactive. So we can perhaps say that an application is close to its deadline and therefore we need to do something about it in case it actually meets the deadline, and because the wall time has been completed, then the application terminates. Why do we have to adapt? We can start considering things such as the context of the environment and the resources available. Can we say a resource has become free and we can make use of it, so can we accelerate an existing application? Where do we want to implement the change? We can do this at various different levels. So we can look at the applications and the software that is running within the system, or we can look at the resources. And these are 2 different things we can adapt. We can look at what types of change is required. So is there parameters or structures in the environment that we can change? Can we shut down a resource, or can we change an application so it has more tasks running, or can the tasks be terminated if they're excessively using resources? We can also look at how the adaptation is performed. So what criteria are we using to actually decide on what adaptation to make, and what the rules will be formed around the system. The manager works within the context of a wider workflow. Firstly, we have HPC developers writing programs in programming models such as the TANGO programming model to actually deploy onto the HPC environments. What we can actually have is we can have multiple different versions of the same application compiled to use different accelerators within the environment. This can then be deployed using the application lifecycle deployment engine, which will manage these different versions of the application and allow them to be deployed on the device supervisor. So we have various different configurations of the same application which are available. The device supervisor can then deploy these applications onto the heterogeneous devices within the overall system. This allows for the monitoring infrastructure then to monitor these applications along with the heterogeneous devices, and it also allows for the energy modeler to take this information about what's going on in the environment to determine individual applications' power consumption. This therefore allows the Self Adaptation Manager to have information about the devices through the monitoring infrastructure and also applications through the device supervisor. The ALDI provides its information about the various different configurations that are available within the infrastructure for the given applications that may be running. This altogether gives a wide range of options for adaptation. The Adaptation Manager has various different types of event that it can generate. As previously discussed, it can detect things such as idle hosts and idle hosts with accelerators. It can detect things such as applications starting and completing, or when they approach their deadline. It also has the prospect of using cron statements, so indicating particular times of the day or recurring events within the system. What we see is a table below which has a sequence of 9 different rules. Some of these cover aspects such as detection of idle hosts and applications finishing, and others detect measurements such as particular power consumption of a given host. And in particular we see rule number 7, which is specified against a particular host as saying that the CPU measured shouldn't reach a value above 1. We can also see application power consumption, and in the case of rule 9 we can see the application power consumption of an application called Arcade Bench mustn't exceed a value of 50 watts. Monitoring events have actually been written, you then need to start considering the mappings between the event and the actual response that needs to occur. Through a sequence of rules that performs the mapping between the event and the response that is gained. So what we can see is various things such as the application finishing, and that other versions of the application should be killed off. And this is restricted to applications which are called comps. The second rule that is highlighted is the application power consumption. So what we see is that if the power consumption reaches over a given threshold, then the application will be killed off. What we are going to now do is demonstrate these rules which have been highlighted and the associated events into demos. What I'm going to show you is the Self Adaptation Manager cancelling an application based upon an application power level constraint. So I'm first going to show you the sort of Grafana interface and its use of the application power consumption. So what we can see is various applications which have been running fairly recently and how much power they've been consuming at any given time. We can also see the host power level consumption. I'm then going to move on to start the Self Adaptation Manager. And what we can see is we can see various rules that have been loaded, such as the ones shown here. So we can see if the power consumption of a given application called Arcade Bench gets too high, then we're going to kill the application off. So I'm then going to move on to the next stage of actually running the application. So I've just started it. We can see it queued and running. And then we're just going to watch and wait till it gets to a point where the power consumption goes too high. What we can see now is that the Adaptation Manager has just detected the application's power consumption has gone too high. It's performed some adaptation and the application is now no longer running. So if I now do SQ again, we can see the application has gone, and if we look at the history of applications running, the very last application here has been cancelled. and it has been cancelled because the power consumption has gone too high. So if I look at my application's response log, we can see that the application's power consumption was too high and it performed the action of cancelling the application. So what you see on the screen is that various rules of the Self Adaptation Manager have been loaded into memory. And what we're then going to do is we're going to run a comps application, one which uses a CPU and the second which runs the CPU and the GPU. They're going to run together for a period of time simultaneously. What's then going to happen is one of these applications is going to finish. And we're going to look at the rules which are available in the Self Adaptation Manager, and this last one, on completion of a comps job, it will actually kill all of the similar applications. So what we're trying to do is we're trying to get two implementations of the same application running at the same time, and once one completes, we're going to kill the slower running job. So we've got the results and we no longer need the second job running. So now what I'm going to do is I'm going to follow these commands here, and I'm going to type them into the actual console, and this is going to give me the comps runtime activated. So I've loaded the comps runtime, and now we can start the jobs running. So if I start the first one, so CPU only, I can start that running now. So I'll just give that a second to load. And now I can show you that that one is running. So that's one job running, and if I now load the second one, we can see that running now as well. So the first job has been running for about 30 seconds and the second job has just started. And we'll see which one actually completes first. What we can now do is we can start looking at the output from the Self Adaptation Manager. So in a minute or so's time, we're going to start performing work, and what has happened is one of these jobs has finished. So the work being performed is that it cancels the second job. So if I look at SQ again, we've got no jobs there, and then if we look at the previous jobs that have run, we see the last one. So we've got job 3285 and 3286, and the latter one has been cancelled because the first one is completed. We can actually see also when it's running, if I just refresh this, that we have two jobs running, and this is showing the application power consumption and the host power consumption for this job. So we can see additionally that the energy modeler within the architecture is working. And they both complete at roughly the same time. So no further record is given. Now that we've seen demonstrations of the Self Adaptation Manager, we can consider that it can be used to very many different cases. For example, we can see when hardware becomes available. This can be used for quality of service improvement. So if an application is running, we can cancel the existing instance of the application and start a version of it which is running on an accelerator. And therefore, we can use potentially less power, or we can get the application to run quicker. We can also do other things such as power smoothing and energy saving. So we can start applying things such as thresholds on given applications to ensure that no individual application is using too much power consumption. We can pause applications when they do use too much power at a given time of day, and then we can awaken them later to run when there's less overall demand. We can also look at things like benchmarking of applications as seen in the demonstration, so we can run two implementations of the same application side by side and see which is the most energy efficient, which is the quickest, which is the one which uses the least power. We can also look at the forms of adaptation that we can actually perform with the Self Adaptation Manager. We can do things like extend the wall time or reduce the wall time to improve packing of applications. We can kill applications off, or we can kill similar applications, not just a given application which has been the cause of a given event. We can pause and resume applications, or again act upon a whole series of applications at once. We can reselect accelerators by redeploying the application using information given by the ALDI and actually choose a different configuration for the application and run that instead. We can also look at things such as adding and removing CPUs from pending jobs, or removing nodes as well, or oversubscribing or making an application exclusive to given resources. Rule flexibility can go further, such as cancelling a previous action that has occurred. So perhaps we pause an application at a given time of day, and then after a given period of time we want to unpause it. You can also look at things such as temporal parameters as well. So we can specify starting times for given rules to occur and ending times. We can also make sure rules are applied at any given certain times of the week, for example Monday to Friday. This therefore allows us to use rules in a more intelligent way, so we can actually have different periods of time, such as working hours, treated differently as compared to out of hours work.